Okay. Good evening. Can you hear me? Yes, you can hear me, right? Oh, wait a minute. Give me a second. Okay. Last week we discussed about the moment of force, right? All theory parts we completed. Uh, yeah, everything's there. Everyone's there, right? Yes. Okay, we discussed about moment of forces. I given two homework, right? Do you remember homework? Are you complete? Did you complete? Yeah, before that, I will explain what is the basic of moment of force. Before that, next week you have an exam, right? Your second revision exam. Uh, Second revision exam. It's a online exam. It is 2 hour and 2.5 hour exam. I will share today evening. I will share what is the structure and what are the lessons coming in the exam. You can ready. You have 8 days. 27, no? Abhi? 27th of January, right? We schedule 27th morning. Yeah, 27th morning. 8:30. 2.5 hours is still, the paper is not finalized. Probably it will be 3 hour paper. Especially you have ready for force lesson. Lot of questions based on force lesson. Before that, we have today. Today we have 2 hours, and next Tuesday we have 3 hours. More than 3 hours, right? I hope to discuss all past papers and model papers, force questions, force related, all questions I have to discuss, and you can ready for the force lesson. Advanced questions now. Uh, Now exams are standard. I think you know. Uh, Not like 2022-23 papers, exam papers. 25 paper is little bit advanced. It is a standard paper, exam paper. I told. Exam paper is a standard paper. Therefore, 26 exam paper also same level. They are little bit advanced standard papers. Not only SFT, all other subject and all other streams. All other streams it is same. Okay, therefore, it is, as I told, every day you have very limited time. You are a special batch actually. Now, after one exam, for all batch has 11 months for revision, 11 months for our revision, and after 12 months is then overall one year. 12 month is the exam, but this is January. The exam August, and now this is the end of January, and you have another uh, February, March, April, June, July. You have only 5 months for ready for the exam. This is the end of January. You have another 1 week. And therefore, very limited time. You have a huge workload. Now, therefore, your time management and everything, your manage your three subjects. It is very important for this very limited time period. Okay, therefore, time is very important now. Don't waste any day or any hour actually. It is very important these days. Now these days you can freely manage your time and you can complete maximum. I told at least end of April. April අගවෙද්දිවත් ඔයාලට complete කරගන්න පුළුවන් at least 80 or 80 more than 80% of all subjects. If you can complete, then remain 2 months, remain 3 months, May, June and July. You can easily manage your revise and you can easily ready for the exam. If not, you will be trouble. Even at not, it is very difficult task. Okay, you have 3 months. This first 3 months is very important. Medicaid, if you can maximum cover within this first 3 months, that mean first 3 months mean February, March, April. The final 3 months very easy. Okay. Okay, we discussed about moment of forces. Now we are doing mid of the, actually not mid, final part of the force lesson. If any student newly joined with revision, you have to go to our previous video and quickly complete within May, January වලම complete කරන්න අපි දැනට කරපු ටික January ටික. Otherwise don't keep anything to do later. It is very difficult because February plan, you have a huge workload. It's not easy. Therefore you have now other covered the today 18, no? You have 12 days. You have to complete everything we did in January month within these 11 months. Then you can easily continue with our February work plan. Okay, moment of force. Okay, moment of forces. What's the meaning of the moment of force? මම ඔක්කොම කියලා දෙන්නේ. Already explained. What's the meaning of moment of force? Any object ability to rotate around any reference point. The ability to rotate around any reference or fixed point. Ability to rotate around any fixed point by an external force. The ability to rotate. Okay, there are two main factors affecting moment of forces. This applied force Fn, the perpendicular distance between this force and fixed point. Then how we calculate the moment of force? What is the equation? Moment of force equal applied force multiplied by the perpendicular distance. It is not the distance, perpendicular distance between 2 points. Perpendicular distance between force and fixed point. Okay, that's the story. That's a basic. That's why this is a thing we called in short form F into D. The moment of force equal F into D. What is the unit? Newton meter. Newton meter is the unit that you already discussed. Newton meter. Newton meter is the standard unit. Newton meter. Okay, this is a moment of forces. What's the moment of force? Any object rotate around fixed point by an applied external force. That's a moment of force. There are two main factors affect on moment of forces: applied force and the perpendicular distance. Not the distance, perpendicular distance between force and fixed point. What is the equation? The moment of force equal applied force multiplied by the perpendicular distance between force and fixed point. In short form, the moment of force equal F into D. Moment of force equal F into D. Okay, next part, we discussed about direction of moment of force, right? Direction of moment of force. Direction of moment of force, මේ මම කරපුවම කරන්නේ ආයි. Direction of moment of force. Direction of moment of force. If we think F1, think it is F2. This is D2. The distance between the rotating point is O. This is D1, this length. Then how we get the we call, if you forget about, if you only consider this left side, what is this? What is the direction? Is it clockwise or anti-clockwise? I told for moment of forces, that means rotation, we have two directions, clockwise direction and anti-clockwise direction. Clockwise mean clock direction, anti-clockwise mean opposite direction of the clock direction. They are simple. Right. Now the F1 force rotate in clockwise direction or anti-clockwise direction? Quickly. The F1 force yes, very good. F1 force rotate anti-clockwise direction. Good, anti-clockwise direction, because it is, this is the left side direction, rotate into our left side direction, right? This is anti-clockwise direction. F2 force rotate around O point. What is the direction? F2 point. This is the direction. F2 point. Yes, it is good. It is clockwise direction. F2 force clockwise direction, F1 anti-clockwise direction. Now, if you got clockwise moment of force, clockwise moment of force, clockwise moment of force, what is it? What is a clockwise moment of force in for this given structure, given force system? Clockwise, it is F2 into D2 that we discussed. F2 into D2. If you got anti-clockwise moment of force, anti-clockwise moment of force, anti-clockwise moment of force, F1 into D1, right? F1 into D1. Clockwise moment of force, it's rotate clockwise direction, clock side direction, clock ke aage karake. Anti-clockwise mean it's rotate in opposite direction. Okay, now if this system equilibrium, final point that we discussed in the theory part, if this system is equilibrium, how do they make a balance now? If this system is balanced, what is the point? What happened to this moment, clockwise moment of force and anti-clockwise moment of force? Yes, if this system is balanced, if this system is balanced, if this system is balanced, what happened? At equilibrium, equilibrium means balance. Okay, equilibrium, at equilibrium, what is the theory? Clockwise, the sum of clockwise moment of force equal to the sum of anti-clockwise moment of force. Sum of clockwise moment of force, CMF means moment of clockwise moment of force, equal to the sum of anti-clockwise moment of force. Anti-clockwise moment of force. The sum of clockwise moment of force equal to the sum of anti-clockwise moment of force. It is sum important. Sum at the end. Other questions, you can understand why we call it is sum of moment, clockwise moment of force. Okay, now what is the sum of moment of force for above force system? Clockwise moment of force. Clockwise moment of force only one. It is F2 D2. Anti-clockwise moment of force F1 D1. F1 D1. F1 D1. This is the, if the system is equilibrium or balance, this is the This is a theory, this is a concept. It's the sum of clockwise moment of force equal to the sum of anti-clockwise moment of force. Sum of clockwise moment of force equal to the sum of anti-clockwise moment of force. And the same theory I explained in another form. What is this? මම මේකම වෙන විදිහකට කිව්වා. In another form. What is this? Okay, the same thing I can explain. The anti-clockwise moment of force I can get into same direction. F1, sorry, F2 D2, it is plus F1 D1, that means anti-clockwise moment of force මෙහෙට ගත්තම it is get into left side, then what happened? It's converted to minus, right? Make a plus, plus convert to minus. Then F1 D1. What is answer? 0. I told another concept, another theory point. If you got the summation of clockwise and anti-clockwise movement of forces using clockwise direction plus values and anti-clockwise direction minus value, what is the summation value? It's always 0 if the system is balanced only. මේ ඔක්කොම වෙන්නේ මොන වෙලාවෙදිද? If the system is balanced or equilibrium. The system is balanced or equilibrium. Okay, now I given two homework, no? Abi homework kiyad dunnada? Two, yes. Let's go to homework. Yes, I have a question. This is the first one. Okay, very basic level to advanced calculations we discussed today. I'm not going to explain about very basic things. Now I'm going to start from our last day stop point. Today I hope to discuss two past paper questions as well, if we have time. If not, we can discuss it in Tuesday. We have time. Before exam, I hope to discuss every parts of the force lesson. And next month, I hope to cover two revising lessons, and this we can discuss the exam paper as well. This is the O point, rotating point. 2 meter, 3 meter, 2 Newton, 1 Newton. Yeah, what is the value of X if the system is equilibrium? The system already equilibrium, balance. Now, what is the value of X? What is the value of X? I got. What is your answers? Fatima, I got. Dehini? Over there. At equilibrium, what is the theory? Okay, now I can mark 5 Newton. How? What is the direction? 5 Newton rotation direction, anti-clockwise. 3 Newton anti-clockwise. 2 Newton anti-clockwise. Only 1 Newton is clockwise direction. Only 1 Newton in clockwise direction. Only 1 Newton in clockwise direction. Hi. Well, 1 Newton clockwise direction, right? Then I am going to get the moment of forces around O point. Moment of forces around O point. 1 into 5. 1 into 5 clockwise direction. Therefore, it is plus 1 into 5. 1 into 5. Minus 2 anti-clockwise direction, right? 2 into 2. 2 into 2. Minus 3 anti-clockwise direction, 3 into x, 3 into x, 3x, minus 5 anti-clockwise direction, 5 into, what is the distance? 5 into, Tanya, what is the distance? The rotation point mean O and 5. What is the perpendicular distance? They are the most important points. Today you can understand how they ask in the exam. Exam, very advanced questions. Past paper questions, okay? Hurry. Anyone? What is the distance between rotational point X, sorry, O and 5 Newton force? Very good. 2 plus X, very good. Not 2 into X, 2 plus X. 2 plus X. 2 plus X. 5 into 2 plus X. FD equal to what? If it is balanced, it is equal to 0. It's equal to 0. Now, 1 into 5, it is 5 minus 4 minus 3x minus 5 into 2, 10. Plus minus, it is minus. Minus 5 into x, 5x equals 0. Equals 0. Okay, now minus, sorry, 5 minus 4, it is 1, right? 5 minus 4, it is 1. 1 minus 10. 1 minus 10, what is the value? Plus 1 minus 10. It is minus 9, right? Minus 9. And මෙතනින් අපිට එනවා minus 9. Minus 9 minus 3x minus 5x. What is the answer? Minus 8x. Minus 8x equals 0. Minus 8x equals 0. Now, I'm going to get this minus 8x into plus direction. right side direction, minus 9 equal 8x. 8x. Now what is my target? To calculate the x. To calculate the x equal minus 9 over 8. Minus 9 over 8. The answer minus 1 point value. But we calculate the distance. No, distance cannot be minus value. Therefore, the same answer you can place in, you can keep in as a positive value. No problem. No issue. What is the answer? 9 over 8. 9 over 8. Habir, what is the answer? 9 over 8. 1.125 meters. Don't add minus value because it's a distance. Meter. Yes, meter. 1.125 meters. Who correct this? Raise hand. Kavdhari. Yeah, very good. Okay, if you have any mistake, please correct. Dehini correct? Tanya, Harida? Okay, great. Okay, can I erase? Kabir, correct? Joel, correct? Oh, correct this. You have to honest. Okay, then if you all are correct, then I'm skip this part and I'm going to next part. Therefore, you have to honestly say if you correct or understood or everything. You have to honestly say. Joel, what is the mistake? Calculation error or substitution error? Oh, correct this. Let's see. Let's try next one. Okay, let's go to second one. This is our point, rotational point. 3 meter, 2 meter, 40 Newton, 2 Newton, 10 Newton. This is F. Harne, the diagram is correct, right? F. Am I correct? Make it change the man. They are doing it. Joel? Where it is 100? I change it 100, no? Yes. No, I change it into 100. Now, okay? Yeah, this is the second question. Okay, I need to get this F force. The system already equilibrium. System already equilibrium. Okay, what is the method? Okay, where we can start? First of all, the F force is not perpendicular to the distance. No, therefore, we have to resolve this force into the perpendicular direction. Now, first we can resolve if you got the resolution component, force resolution. Before last week we discussed, right? Force resolution. You can use force resolution to resolve this F force into perpendicular direction. Now that this issue okay, now others are everything okay. Now you can mark this is the rotational point. This is a rotational point, and 40 Newton anti-clockwise, 2 Newton anti-clockwise, 100 Newton clockwise, F Newton, F clockwise or anti-clockwise, F. Now it is, if you resolve, it is not F, F sine 30, right? F sine 30. F sine 30, what is the direction? Clockwise or anti-clockwise? Madhu? F sine 30, clockwise or anti-clockwise? Good. It is anti-clockwise because rotate into left side direction. Good. All right. Let's start. I'm going to zoom out, please. Okay. Okay, I'm going to start. Yeah, where we can start? Going to Patangan. Yeah, better to start this end. Okay, I'm going to get moment at equilibrium. At equilibrium, if you want full marks, this type question, you have to follow all these steps. Your main purpose in the exam, you have to show to the examiner you everything of this part you already know. Then if you follow all these methods, if you follow all these standard method for all answers, you can easily get positive attitude of the examiner at the paper mark karna officer. Okay, it is very important. Then it will be advantage for you. Okay, then at equilibrium, there's standard methods. Okay, I'm going to get moment of force around O point. This is my reference direction. I think clockwise directions is a positive. That's why I add this mark. The moment of force around a point, I think the system rotating clockwise. Therefore, clockwise moment of force positive direction, anti-clockwise moment of force negative direction. මේක උනා අනිත් පැත්ත කරන්න පුළුවන් same answer. If you want, you can do opposite direction. That means anti-clockwise positive and clockwise minus use කරන්න පුළුවන්. No problem. But this is an easy method. Okay, f sin 30. F sin 30 anti-clockwise. Therefore, f sin minus f sin 30. What is the distance? F sin 30. What is the perpendicular direction? Not direction, distance. Perpendicular distance. It is the perpendicular distance, not 2. They are the very important things. The perpendicular distance between force and, that means applied force, considering force and rotational axis, rotating point. The rotating point O, what is the distance? 3 meter. Now it is 3. The minus important. Minus important. Now 100 Newton clockwise direction. Therefore, it is plus 100 into 1. 100 into 1. 40 Newton anti-clockwise direction. 40 Newton anti-clockwise direction. 40 into minus 40 into 3. The distance 3. Minus again 2 Newton anti-clockwise direction. 2 into what is the distance? What is the distance between rotational point and 2? Final force. Is it 3 or 2? 3 or 2? It is 5. Good. Then 2 into 5. 2 into 5 equals 0. Equals 0 because the system equilibrium. System is equilibrium. Okay, now f sin 30, you know sin 30 equal half, right? That we discussed in the force resolution also. F sin 30 is half. Now minus, f is a constant, we don't know, still we don't know. Sin 30 value half. Sin 30 value half into 3. Into 3, still it's minus, plus 100 into 1 equal 100, minus 40 into 3, 120, minus 5 into 2, 10, equals 0. Now let's simplify this. 3 and 2, it is 1.5. Now 1.5f, 1.5f, minus 1.5f, minus 1.5f, plus 100, minus 120, minus 10. What is the value? Plus 100, minus 120, minus 10. What is the value? What is the value of this part? Minus 30, right? Minus 30. Minus 30 equals 0. Now I am going to get this minus 30 into this direction. Right side direction. Minus 1.5f equal 30. Now what is my requirement to get the f? To get the f equal 30 divided by minus 1.5. What is the answer? 30 over 1.5. What is the answer? 15. Sorry, 20 Newton Why it is minus 20? Yes, answer minus 20. Why it is minus 20? What is the reason? Why it is minus 20? Why this answer is minus 20? What is the reason? In the theory lessons, I explained what is the reason for this. No, no, Kabir, it is not the reason. Now it is perpendicular now. Now it is we got the perpendicular force now. F sine 30 we got. Now it is perpendicular. This force component is perpendicular, but it has a specific reason. Anyone? What is the reason for this minus value? Dehini. Fatima? Yes. This F force is, if you got this F force as clockwise moment of force, actually it has an anti-clockwise moment of force. It can be F එක but in exam your answer is correct, but you have to mention 20 Newton force, 20 Newton force, 20 Newton force act on opposite direction. It is acting on opposite direction. That's why it came minus value. For distance minus value work out, it's okay. Distance cannot be minus value. You can give as a positive value. It's okay. But if the force minus value, if you got force minus value, you have to explain the applied force act on opposite directions in the marked direction from the figure. Understood? Hari. Okay, let's discuss only one question and let's move into our exam questions. Actually, couple of forces and we have only couple of forces. And force equilibrium we already discussed. Now we discuss force equilibrium. Force equilibrium I hope to discuss through questions. Therefore, after this part, we can go to our exam questions. Okay, final one. Let's calculate. It's 0.5 meter and it is 2 meter. Okay, let's calculate the x distance. If the system is balanced or equilibrium, let's calculate the x distance quickly. Okay, complete. I need x distance. This is clockwise, anti-clockwise, clockwise. After resolute, this component is clockwise. Clockwise, sorry, anti-clockwise. That this one clockwise. First, you can mark these forces, direction. Then you can substitute. Clockwise, I'm going to start from this final 40 Newton force. 40 into, it is plus 40 into 1 plus x. 1 plus x minus 30 into x, 30x minus 30 sine 30. What is the value? Sine 30 half. Sine 30 half, then the force component 50. Resolute component 15. 15 Newton is a component. Then you can use 15 into 0.5 or half. Anticlockwise. Finally, plus 20 into 2.5 equal to 0. Now 40 into 1, 40, 40x, 40x minus 30x minus 15 into 0.5, it is 7.5 plus 20 into 2.5, it is 50, no? 50 equals 0. Plus 40x minus 30x plus 10x plus no need plus 10x 40 minus, sorry, 40, yes, correct, 40 minus 7.5, 40 minus 7.5 plus 50, what is the value? $92.5 plus 92.5 equals 0. Now 10x equal minus 92.5. X equal 9 point, don't think about minus, 9.25 meter. Oh, this answer 40, yeah, mistake. 40 minus 7.5, it is 32.5. 32.5, 82.5, mistake. 82.5, then 82.5 mean 8.25, right? Now, okay. No, Joel, the order is not a problem. But you plus and minus, if you correctly add, substitute, order is not a factor. You are correct. Answer එක ආව නේද? You got same answer, no problem. Okay. Everyone complete? I'm going to erase. Okay, complete. Now, okay, let's discuss this question. Okay, before that, I want to explain I want to finish first lesson. Yes. Uh, yes, moment of up to moment of force completed. Yes, they are the examples for moment of force. The spanner, the rotation of spanner, bicycle paddle, and wheelbarrow. Wheelbarrow, this is the rotational motion, rotational point, and it is rotate around this point, right? This is moment of force. Moment of force. Okay, our next part, couple of force. What are the meaning of couple of forces? Couple of forces. Couple forces mean two forces. No, couple mean two. Okay, couple mean two. If two forces, consider as couple of forces, they should no, another couple of forces, not same direction. Couple of forces mean, however, it is two forces with three main characteristics. The first main characteristic, couple of forces are two forces acting along opposite directions. Act along opposite directions. That's the main characteristic. Along opposite directions. Opposite directions. Two forces acting along opposite directions, and they are same magnitude, not direction. Nadu. They are same in magnitude. Same magnitude. And third one, that means opposite in direction opposite, and same magnitude, like this. Opposite in direction. Now it is opposite. 5 Newton, same magnitude. Is it couple of force? Is it couple of force? Joel? Is it couple of force? Is it couple of force? Yes or no? Now up to now all characteristics they are right. Acting along opposite direction, and the two force magnitudes are same. No, still not a couple of force. Couple of force in none. Two forces acting along two lines. That means two forces, not linear forces, not linear two forces. It should be non-linear. Okay, now two forces acting along opposite, that's okay. Same in magnitude, that one also okay. But these two forces in same direction, not same direction, same line. They acting on same line. If it is couple of force, they should in same magnitude and opposite direction. They act on two directions, two lines. That is very important. The final factor also very important to consider as. Now, if you got 5 Newton, okay, that's the meaning of the couple of force. Two forces acting along opposite direction and same magnitude in two lines, or non-linear forces we called as couple of forces. Understood? Nadul? Two forces acting along opposite directions, same magnitude, and act along two lines called as couple of forces. Okay, let's move into our definition. Two forces of equal magnitude acting on opposite directions, equal magnitude, opposite directions along two lines of acting. They are very important. Along two lines of acting are known as couple of force, like this. F and F, two forces acting along opposite direction, same magnitude, F and F, but in two lines. Two lines. Okay, tell me examples for couple of forces. What are the examples for couple of forces? Yes, water tap. Water tap. This is a water tap. By our two fingers, one force applied this direction, other force applied this direction with same magnitude. What else? Steering wheel. Steering wheel. Steering wheel. Steering wheel. One force applied this direction, another force applied this direction. Same magnitude, opposite directions, two lines. Two lines, right? Now it is rotated to one direction. What else? Another examples? Tamana. Yeah, water tap. You mean water tap? We discussed. I asked what else? Other example. To opening a lid. To open a lid. Yeah, steering wheel also we discussed. What else? Other example? Venomana. Yes, screwdriver. Yes, screwdriver. Yes, when we apply force, it's acting two lines, right? Opposite direction, same magnitude. Opening or closing a lid of a bottle. Yes. Sharpening a pencil. Yes. Yeah, that one also. Yes, good. Okay. Now, if you have idea, you can think examples and write down. Okay, now we have another point. We have another part. The moment of couple of force. The moment of couple of force. That mean moment of couple of force mean the couple of force also type of moment of force. That one also rotating, right? That one also rotating around fixed point. Now the moment of couple of force mean the moment of force of couple of force, but the equation of this moment of couple of force little bit different from our basic equation, basic moment of force equation. Think now this is a moment of couple of force. Now think this is the moment of force. Sorry, couple of force. Couple of force. 10 Newton, 10 Newton. The perpendicular distance between two forces 1 meter or 2 meter. 2 meter, the distance. Okay, how to calculate the moment of couple of force? It is very simple. Moment of couple of force equal to the applied one force, not both forces, one force value. One force value multiplied by the perpendicular distance between force. Perpendicular distance between force. Okay, now what is the moment of couple of force of the given couple of force? Moment of couple. The moment of couple one force value 10 Newton, not 20 Newton. One force value. It is one applied force value 10 Newton multiplied by the perpendicular distance between two forces 2 Newton. So 2 meter. Now what is the moment of couple of force? 20 Newton meter. The unit same, the method same, but always remember for moment of couple of force, always we get the distance between two forces, not the distance from the fixed point. Distance between perpendicular distance between two forces. That's the difference. That's the difference. Let's go to our tut. The moment of couple of force equal force multiplied by perpendicular distance. It is one force. Force mean one force. Value one force value multiplied by the perpendicular distance between the line of action of two forces. Line of action mean the distance between two forces. Line of action mean this distance. Okay. Okay, they are the examples: water tap and screwdriver, steering wheels. Okay. They are the examples. Okay, we have 30 minutes to discuss question. Okay, this is our final part of the lesson. Force equilibrium. Force equilibrium of moment of force equilibrium already discussed. In the moment of force, that means object is rotating. How to get the equilibrium of balance? How we can identify if it moment of clockwise moment of force equal to the anti-clockwise moment of force, or geometrical summation of moment of force is 0, the system is already balanced or equilibrium under moment of force. But now do we remember in the Newton's law lesson in the second day of the first lesson, I explained about Newton's law lesson. I explained in the first law, if any object don't have unbalanced force, what happened? If any object don't have unbalanced force, that means it's already balanced. If any object don't have unbalanced force, its rest objects rest and moving objects moving with uniform velocity. Understood? Do you remember? If any object don't have any unbalanced force, that means it's already balanced. Rest object rest object keep rest and moving objects moving with uniform velocity. That is a Newton's first law. Now what you need to understand, that is actually equilibrium under linear motion. First law equilibrium. Force equilibrium under linear motion. What is the point? If any object don't have unbalanced force, or if any object don't have resultant force. In the resultant force lesson we discussed previous, if any object don't have any R value, that means R value 0, like this. Now think it is 20 Newton, 10 Newton, 10 Newton. What is the resultant force act on this object? What is the resultant force act on this object? What is R? Samya? What is the resultant force act on this object? Very good. It is 0. 0 Newton resultant force. Now tell me, if it is resultant force 0, how about this object? Is it balanced or unbalanced? Okay, this is very good. It is already equilibrium. This object is balanced. Okay, that's the point you need to understand. If you think, if there are this object 5 Newton, 2 Newton, what happened? It has a resultant force, unbalanced force 3 Newton into right side direction. Okay, now I can say if this balanced object no any unbalanced force or resultant force. If this object rest, if this object moving, it is moving with uniform velocity. Okay, this is the point. This is Newton's first law explained. Okay, Newton's second law explain if any object unbalanced, what happened to this object? If any object unbalanced, it's always moving, right? It's always moving with what? It's always moving with, according to Newton's second law, the object always moving with acceleration. The object always moving with acceleration. That means this object accelerate into resultant force, unbalanced force direction. It has an acceleration. That's why we got always accelerate. If it is moving, it is always accelerating. This accelerate we can get by Newton's second law equation, F equal ma. This equation you have to very carefully understand. The F is not the force. Still you doing this mistake. F is not the force. What is the meaning? What is the name of the F in the Newton's second law equation? F equal ma. What is the F name? It is unbalanced or resultant force. Mea tama F. Unbalanced or resultant force equal to mass into acceleration. Okay, that's the thing. If any object don't have resultant force, it's already balanced and it's always rest or moving with uniform velocity. If any object is unbalanced, that means it has a resultant force. It's always accelerate into resultant force direction. F equal ma equation. F mean what? Not the force, it is resultant force act on this object. Okay, that's the entire lesson. And we have another final part. We have another part, the equilibrium under three forces. The equilibrium under three forces. Equilibrium under three forces. Now think this is a point. There are three forces act on this object. F1, F2, F3. Okay, how to get the resultant force of this system? How to get the resultant force? Do you remember? Three forces acting on same point. What is a equilibrium under three forces? Equilibrium under three forces. Okay, how to balance three forces? How to balance three forces? Do you remember? If you not remember, let's go to our, this is 2021 or 2. Paper 2023 exam paper. Okay, let's start. A rigid body maintains its equilibrium. Rigid body maintains its equilibrium under three coplanar forces. I forgot, you have to get printouts of all past papers. All past papers you can download in our website. I have already uploaded. You can freely download them. Mark scheme also there, but you don't need to get printouts of mark scheme. I will give you all answers for all questions in final few after April. You have to get printouts. All past papers, not only SFT, other subjects also, ET and other VST. Also you have, now you have with 2025 paper, you have 11 past papers. 11 past papers. 2025 paper structured part still not released. I have only essay part and MCQ part only. Normally within two, with result normally it will be released. Let's try to get the structured essay. I'll ask from education department to get the structured part. However, you have MCQ part and essay part. You have get printouts, and you can try your own these questions now. අපි කරපුවා දැන් course lesson biomolecules lesson we discussed a lot of questions, but you can find more questions in past papers and model paper. I'll give you all model papers. You have to get printouts of past papers. Now you can try. I think 2019 also post lesson question. You can try. I will discuss before that. You can try. A rigid body maintains its equilibrium under three coplanar forces. State the three requirement. This is a theory. It is directly asking. දැන් මම අතන question එක ඇහුවෙත් මේක තමයි. State the three requirements that must be fulfilled by the resultant force of two forces. Resultant force of two forces. Two of these forces and third force maintain equilibrium. Okay, do you remember? This is a 2023 paper. Now two forces F1 and F2 and F3, if they are equilibrium, what are the conditions? Okay, this is the condition. If we got resultant force of any two force, resultant force of any two force, I am going to get the resultant force of F1 and F2. It is RF. This RF equal magnitude with F3. Okay, they are the three main requirement. They are the three main requirement. The resultant force of any two forces equal magnitude, equal in magnitude, equal in magnitude. Equal in magnitude or same in magnitude. Equal in magnitude and opposite in direction, right? Opposite in direction. They are the condition. They are the, now don't mix up with couple of forces. Couple of forces mean two forces acting along same opposite direction, same magnitude, then two lines. Two lines acting along two lines. That is very important. But it is difference. Equal in magnitude, opposite in direction. May they same, they came opposite in direction. Opposite in direction. Final one, both this resultant force of any two force, same line to the remain force. Act on same line. Act on same line. Okay, that's the difference. Same line. That should be linear. This resultant force and the remain force, same line. That means linear. Linear. Okay, let's complete this part and go to the question, right? Okay, equilibrium part, you can read these stories. Okay, this is the equilibrium under three forces. That's our final theory part. The question came from final theory part, this part. Those three forces must be one dimensional. One dimensional means same plane. Three result, the result of any two force. The result of any two of three forces must be equal magnitude, opposite direction to the third force. Okay, the other, okay, that's same. It's one part is missing here. Those three forces must be, please correct this, the result of any two force must be equal in magnitude, opposite and direction, and act on same line. Please add this point as an act on same line to the third force. Now correct. Okay, they are the three main characteristics. Okay, this is the end of theory part of the course lesson. If you missed any part, please go to recordings and complete all theory parts because next Tuesday exam, not next Tuesday, 27th Tuesday exam, it will be very important. These four lessons, theory parts and its applications, very important. Okay. Okay, let's discuss few questions and you have homework today. Okay, now tell me answer. A rigid body maintains its equilibrium under three forces. State the three requirements that must be fulfilled by the result of any two of these forces and the third force to maintain equilibrium. Okay, what are the requirements? Same magnitude, opposite in direction, and what is the final one? Act on same line with third force. Act on same line with third force. Same magnitude. They are the answers. We are doing 2023 essay, 9th essay part. Opposite direction. Act on same line with third force. Act on same line with third force. Okay, they are the three main factors. They are the answers. Equal in magnitude, opposite in direction, act on same line with the remain force. Okay. Okay. Okay, complete. Yes. Okay, now note down this week your homeworks. Coming Tuesday we have 4 hours now. I hope to discuss all force application questions. Okay, note down homeworks. Question 2022-23, that means actually 2022 paper. 23 main exam held year. 2022 paper, question number 9, essay question, full question with this. Okay, that's a very important, very good question. You can try this. You can try this moment of force. Then we discussed this type. We discussed this type question, right? We discussed this type question. This type question we discussed. If the system equilibrium, we discussed this type question we solve. But the same system, it is in inclined way. Inclined way can make it rotate karla diyen. The same system rotate. Okay, you can try. They are very good questions. Okay, and you have another homework. You have another homework. Note down 2022 question number 9. How is it? 2022 question number 9. First part I explained. You have to homework is calculation part. I will discuss this all questions Tuesday class. Before that, you have to complete. Next homework. Give me a second. Yeah, this 2019. 2019. I think same question number. You can download all papers our website. In the home page, you can find download papers. You can click this and download all papers. Yeah, this is a question. The same question, moment of force. Okay, you can try this. Same question number 2019, question number 9 and yes, they are the homeworks. 2019 question number, essay question number 9. 2022 essay question number 9. Okay, let's discuss all questions in Tuesday. On Tuesday we have 3.5 hours. Okay, any doubt from force lesson? Any doubt? New students, please enroll our website. You can register our website and get all previous recordings and complete these all parts again. In last month, we discussed biomolecule as well. Biomolecules without any point mistake. completely we have discussed, as well as exam questions, model paper questions already completed. Therefore, you have to complete, and don't wait until February, because February month we have another plan. Okay, any doubt from first lesson? Okay, complete this homework and let's meet in Tuesday 6 p.m. to 9:30 to discuss homework, to discuss application questions of first lesson. Goodbye.